So we talked about how just as there are ways that you can prove triangles congruent, there are also ways to prove triangles to be similar. And the first way we talked about is the angle-angle similarity postulate. I would note that if you were absent yesterday, this would be an excellent opportunity to catch up by jotting down the postulate, or you will find it in the book on page 474 and the two theorems on page 475. The angle-angle similarity postulate says that if you have two angles on one triangle that are congruent to the two angles on the other triangle, then the triangles are similar. Okay, here's a question. Why do we only have to show two angles? Why don't we have to show three angles? There's three angles in a triangle. Wait, I'm going to pick somebody. So while I'm getting your popsicle sticks, give the matter some thought. Anna. Remember the question?
I do.
Okay.
I don't know.
Can you answer it? No? Well, think about it. How many degrees does the triangle have? 180. And if the two of the angles are congruent, they're going to equal what? If two angles on one triangle are congruent to two angles on the other triangle, what's their relationship? What? No. No. It's bad. Carla, how about you? That has nothing to do with this. You were here yesterday. Okay, that has nothing to do with my question. My question has nothing to do with this postulate. My question requires you to use your brain. What's the significance if I have two angles on one triangle congruent to two angles on another triangle, Joe?
Because it's the two angles are the same. It's like the triangle equals 180 degrees, so the two sides are the same and they equal the same. So the third one.
Exactly. If if this angle is 50 and this angle is 60, adds up to 110. If this angle is 50 and this angle is 60, adds up to 110. How much does the third angle have to be? 70 in both triangles. We don't need to state that the third angles are congruent. It's automatic. By getting two of the angles congruent, it automatically means that the third angle is congruent. We don't have to bother with it. Okay, so the second one, which as you can see, this is where it got, I've been having problems, so it hasn't been saving. So, if an angle on one triangle is congruent, to an angle of a second triangle, sides that include two angles are proportional and the triangles are similar. And what that meant was if I had this triangle, A, B, C, and I had this triangle, D, E, F, and angle B was congruent to angle E, and then AB over C equal to BC Okay, so that was the second one. Yes. Okay.
I think there was you already knew that you wanted to work.
Yes.
I got a question.
Okay.
Right there, it says, whatever those are.
Okay, let's go back to line.
Like, could the angle be, the angle T be
If only angle T is congruent to angle L, or if you're saying S and R and T and L are all congruent.
no, S,
So instead of S and T, you're having two angles in the same triangle.
no, I mean like S, T, and L.
Right, so all four of these angles are congruent. Is that what you're saying? Yes, it just means they're both isosceles triangles. Yes. Yes, Riley. What? Right out of half trees. Okay. Third one, which is new. Okay, so the side theorem of similarity says that if the corresponding sides of two different triangles are all in proportion, then those two triangles are similar. We've actually done this already. That's where we looked at the corresponding sides and we figured out whether the sides were in ratio. If the ratio is the same, does anyone remember what we call that ratio?
Scale factor.
Scale factor, thank you. Okay, so here we have two triangles. Now you can see we're using the angle-angle similarity postulate. So what I want you to do is I want you to tell me, yes or no, are the two triangles similar? And then also, if they are, how do you know? I want you to be able to explain it to me. Kiera. So, can you answer this first question?
I said yes.
You said yes.
I wanted to answer the next one.
I'll give you a chance. Tyler, what say ye? What say ye? Are they similar?
Yes.
Yes. Is there anybody who does not believe that they are similar? Speak now or forever hold your peace. Okay, Kiera,
Yes.
how do you know they are similar?
I said because the 45. And wait.
with this is that all you're doing is reading Bill's work.
But I said that.
Oh, okay. Okay. Tyler, what's your explanation?
I would say for the vertical angle,
And which are the vertical angles, Tyler?
R and B. Or is it-
Nope.
Oh, okay.
Justin, you're not here today. John, do you know which two angles are the vertical angles? No? You know what the definition of vertical angles are? Yes? No? Okay, this is something you need to know. So you're going to see it a lot. Luigi, which are the two vertical angles?
W and Z.
Nope. Okay, I'm not quite troubled yet. One more wrong answer and I will be troubled. Larry, which are the vertical angles?
What? Now you're trouble.
Which are the two vertical angles in this problem? That's what Luigi said.
Oh, sorry.
Okay, I'm now officially troubled.
I said W.
No, it's W and B. F and B.
Still wrong.
I got it on that.
Joe.
R and W.
Joe.
R and B. No.
Now
Oh my God.
I'm panicking. Riley.
It's S.
Oh, S is a point. I want you to be specific.
No, I was
and tell-
saying yes. Yes, W and B. Oh God.
Bill.
It's WSR.
WSR and BSA. Vertical angles, for those of you who are causing me to cringe, vertical angles are opposite each other.
Yeah, Tyler. Don't even try it. Don't even try it,
Okay, next problem. You are given two triangles. You are told the length of the sides of each of the two triangles. What I want you to do is identify which side corresponds to which, then set up ratios for the pairs of corresponding sides, and then tell me if they are similar, and if they are similar, what you used to prove it. Whether you use angle, side, or side, side. Go. Naya, what say ye? Are these two triangles similar? Yes? What did you do to figure it out?
I did.
Hold on a second. Can we please have your undivided attention, Mr. Sanchez? Brianne, may we have your undivided attention as well? Tyler? Dylan? Anna? Carla? Luigi? Okay, go ahead.
I did SU over YX. No, not YX. WX. And I did 10 over 15. And then I divided it by 5. Yeah, I got that. And then I did it to the other side, and I got that too.
Okay, good. Now, here you kind of want to work backwards a little bit. Anybody who didn't get it? Anybody not get? Yes? Okay, what's the similarity statement? How would you write the similarity statement, Jonathan?
I wrote the triangles are similar by the.
Which triangle? The similarity statement, you have to label the triangle. Because my concern is that on the EOC, it's going to say yes, there's going to be 2 yeses, but the triangles are going to be labeled differently. And if you don't match up the right triangle with the right triangle, Tyler, you're going to be wrong. So it is important that we write the similarity statement correctly. So, how do you want to label this triangle, Jonathan? STU. So we could say that triangle STU is similar to, well, if you're saying STU, how do you call this one? XVW. Brianne, is what Jonathan said correct? Why do you think what Jonathan said is correct? What makes you agree with what Jonathan said, other than he's very bright? And if he says it, it's probably true. But do you have another reason? So how do you know he's right? What? But we don't know anything about the angles here. Excuse me. You don't know? Okay, so now what I'm saying, what I'm asking is, when you label a triangle, you label it a particular way. If we're saying that the triangles are similar, the triangles are only similar if we label them a particular way. If we don't label them correctly, it doesn't appear that they're similar. So, you agreed with Jonathan that this is correct. What I want to know is why. Why do you think that's the correct way to label the triangle? I want you to justify your answer. It's not enough to say yes. You need to be able to explain yourself. Jack, can you explain it?
The last one I went to, is where T is, so that's where E is too. So that
Okay, again, no angles here. We don't know anything about these angles. Andy?
They're similar because you look all of the angles of, because, like what?
Did I not just say we're not talking about the angles?
Not the angles, all the sides, equal out to.
That's not my question.
Oh.
My
And
question
you said,
is,
why is he right? And he's right because it's all.
why is this right? Why is the way that it's written correct? That's what I want to know. Joe?
You got it in by the vertex.
But
How do you know what the vertex is?
well,
Like, any of them could be the vertex.
they're all vertices.
Exactly.
The triangle has 3 of them. Riley?
Correspond.
Which correspond?
That's X, T, W.
That's right. If you label the triangle STU, and you label the triangle XVW, what you're saying is that side ST corresponds with side XV. So does side ST correspond with side XV?
Yes.
Yes, they're both the shortest side on each triangle. And then, so then if ST corresponds with XV, then the last letter remaining is U. That's how you justify your answer. Okay? It's not, the reason that I put so much emphasis on this is that you have to be able to duplicate this. You have to be able to do this. And if you don't understand why that's the correct answer, how are you going to be able to duplicate it? And you see this question on the EOC, and there's 4 answer choices, and all it is the same grouping of letters arranged different ways. How are you going to know which is the right grouping of letters? That's why I'm putting so much emphasis on this, is because it's very likely that the 4 answer choices for this question are going to be 3 ways to label the triangles, and then the 4th way is no, they're not similar. So if you just know that they're similar, all you've done is eliminate one of the answers. But it's not enough to eliminate one of the answers. You have to be able to get the question right. Okay.